In this example problem, we're going to do a little review of the concept of substitution and elimination. We're going to do so by solving the system of equations. For our first equation, we have 0.05x1 minus 0.03x2 is equal to 0.21. In the second equation, we have 0.07x1 plus 0.02x2. That's going to be equal to 0.17. Now, it should be pointed out that with all of these decimals in here, it might be kind of difficult to work with. So if you're interested in getting rid of the decimals, you'll notice that all of these terminate at the hundredths place. So what we're going to do is multiply both of these equations by 100 to clear out all of these decimals. That'll give us 5x1 minus 3x2 is equal to 21, and 7x1 plus 2x2 is equal to 17. Now, because we don't have any coefficients of plus or minus 1 in here, if we wanted to solve this using a substitution, it guarantees that we would have to bring in a fraction. As such, I'm going to go with elimination addition instead. The goal behind elimination addition is to get two coefficients, either the coefficients of x1 or the coefficients of x2, to be equal in magnitude and opposite in sign. Now, you are allowed to multiply both equations by a non-zero constant. I'm going to eliminate the x2 variable. You're allowed to pick either one. However, these already have opposite signs, and that seems nice to me. So I'm going to multiply the first equation by 2 and the second equation by 3 in the hopes that the two coefficients will be plus or minus 6. So distributing the 2 through to all of the terms, we will have 10 times x1 minus 6 times x2 is equal to 42. And the second equation becomes 21x1 plus 6x2. That's going to be equal to 51. At this point, because the coefficients of x2 are equal in magnitude and opposite in size, we can, opposite in signs, we can add these two equations together. 10x1 plus 21x1 will give us 31x1. Negative 6x2 plus 6x2 will cancel out, leaving 0. And 42 plus 51 is 93. Now this is great news for us because 31 goes into 93 really nicely, giving us x1 is equal to 3. Once you have your value for x1, you can head back to either of these two equations here, or you can head back to either of the original equations in order to solve for x2. Arbitrarily, I'm going to go ahead and plug this into the second equation after we canceled out all of the decimals. So 7 times x1 plus 2 times x2, I guess parentheses weren't necessary there, that's going to be equal to 17. Or 21 plus 2 times x2 is equal to 17. This would be considered a two-step equation. The two steps that we're going to take are going to be subtract 21 from both sides to give us 2 times x2 is equal to negative 4. Then divide both sides of the equation by 2, yielding x2 is equal to negative 2. Now to check your answer, just to make sure that everything's working out okay, we got this by plugging it into the second equation. Let's go ahead and take these and plug them into the first equation to verify our solution is correct. So we'll take 5 times x1 minus 3 times x2, and that should be equal to 21. On the left-hand side, I'm seeing 15 minus negative 6. We'll call that 15 plus 6, and that does indeed verify that our result is correct. Now, using the terminology of this section, we would refer to this system as being consistent. It has a single solution, x1 is equal to 3 and x2 is equal to negative 2, and we could even express it as an ordered pair. The lower index would go first, so 3 comma negative 2.